Okay, pre-cal, in this video we are still in Unit 7, okay? And we are going to talk about topic 2. So we're going to be verifying trigonometric identities or trig proofs. So I've just kind of outlined a thought process for you here and some algebraic things to do if you can't use your identities page to replace anything. So the difference between this and topic 1, which we've already explored, is that rather than now trying to create one term without addition, subtraction, or division, i.e. fractions, now I'm giving you where you need to go. So I'm basically going to be grading the steps in the process that you take to get there. So as we explore this, I want to look at number 1. I want to transform what's on the right to what's on the left to what's on the right. So I want to change sine x cotangent x so that it is cosine x. So of course, with this one, since there's just two values multiplied together, sine x and cotangent x, I'm going to head directly to my identity sheet. So when I look at my identities, I know that I can rewrite cotangent so that is cosine over sine, and that will help me because cosine's what I'm after. So when I go back to my notes, I am going to rewrite sine x as just sine x over 1, and I'm going to rewrite cotangent to be cosine x over sine x. And I'm going to write out to the side, this is the quotient, one of the quotient identities, just to guide me, because remember, I'm grading your steps this time, so you're going to name what you're doing. Okay, and then of course, I can just mark through these and I end up with exactly what I need. This was an easy one. So of course, the step I used was reducing. So we're going to do all of these this way. All right, so when I look at number 2, I've got to make this look like this. So what I'm going to do is draw a line right down here. And I'm going to rewrite this on the left as sine theta minus cosine theta squared. So this is what this means. Just like that. And then I'm just going to FOIL it. So I end up with sine squared theta minus cosine theta sine theta minus cosine theta sine theta. I'm going to run out of room, of course. And then positive cosine squared theta. And then I'm just going to combine my like terms. So all I've done so far, I just FOILed that. And then I'm going to combine my like terms. So I've got sine squared theta, I've got one negative cosine theta, sine theta, and another one. So that is 2 of those. And then plus cosine squared theta. So all I did right there, I just combined like terms. All right, now what I'm going to do is I'm done with all the math I can do with this, so as far as algebraic things. So now I'm going to go to my identity sheet. And I remember that when I add sine squared theta and cosine squared theta, I get a 1. So I'm going to go back to my notes here, and I've got sine squared theta plus cosine squared theta, so I'm going to replace that with a 1. And that was, of course, the Pythagorean identity, one of them. So now I've got 1 minus 2 cosine theta sine theta. That's pretty much the same thing. You can leave it that way if you want to, because it doesn't really matter how I write it. So there you go. All right, so let's look at the next one. Number 3, we have cosine x times 1 plus tangent squared x, and I want it to look like secant x. So I'm going to draw a line here. And let's see, I've got tangent squared x, so I'm going to go to my identity sheet and look at my Pythagorean theorem identities, and I am going to see if I can replace that. And sure enough, I can, because if you'll look at identity number 13, that is exactly what I have, and I can replace it with secant squared theta. So I am going to come back over here, and I'm going to write cosine x times secant squared x. And that, of course, is just the Pythagorean theorem identity. Awesome. Now, what I need to do is I need to recognize that now I just need one secant x, and I've got secant squared x right now and a cosine. So again, I'm going to visit my identity sheet, and let's recall that I can rewrite cosine as 1 over secant. So let's do that. So 1 over secant x, and then this is secant squared x is actually secant x times secant x, so I can just write it that way if that helps you see that you can reduce. So of course, the reciprocal identity enabled me to rewrite cosine, and then of course all I have to do is reduce. Life is good. Okay, let's look at number 4. On number 4, I need this right here to look like this. So again, I've got something squared. So let's go back to my identities page and see if there's a Pythagorean theorem identity that will help me. And if you'll notice, this one right here, 1 plus cotangent squared equals cosecant squared. So that's going to help me change this. So now I can write this as 1 over cosecant squared theta. And that, of course, is a Pythagorean theorem identity. And then, if you need to do this in your head so that you can see this clearly, this is the same thing, all right? And mathematically, all I did, I just expanded that. That's called expanding. And you don't necessarily have to write that out or even do this step if you don't want to. But then I know that I can write this as this because it's a reciprocal identity. And if you don't believe me, I'll show you. Reciprocal identity right here. Okay, and then of course, I can just multiply that. And if you did this step right here, then you would of course just say that you multiplied. No big deal. Easy peasy, lemon squeezy.